Hello guys, Lumi here with this is the second day of my daily self-study journey for mathematics, and today it's not calculus, it's actually number theory by the book by Andrews here. It's a Dover book which is affordable, and the first thing I learned about is principle of mathematical induction, which is about a statement about the integer is true for all integers greater than 1 or equal to 1 if it is true for the integer 1, meaning it's true for the smallest case, and it doesn't have to be not 1. Some proofs are start with other numbers, integers, and whenever it's true for the smallest case, then it's true for k plus 1 for the number the next integer. So yeah, well, the first problem. This is the first problem from the first section, which says to prove that 1 squared plus 2 squared plus 3 squared plus dot 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 ellipses plus k squared equals to k plus 1 2k plus 1 multiplied all divided by 6. So let's see. So the successive summation of all the perfect squares is equal to this formula. So yeah, let's start with k plus equal to 1. This is the smallest k we have. So 1 squared equals, for the formula, 1, k plus 1 is 2, 2 multiplied by 1 plus 1 is 3, all divided by 6, which is 1, which is true. It satisfies the smallest case. So now for k plus 1, we will have the same. It will be 1 squared plus 2 squared plus 3 squared plus ellipses plus k squared plus k squared plus 1, our next integer, which is equal to, it will be equal to k plus 1, k plus 2, and 2k plus 1 all to the plus 1 over 6. So we have to get this left side equal to the right side. So let's start. We assume that this formula is true. So we assume this, from this to here, it is k plus 1, 2k plus 1, and divided by 6. And now we will drop this plus k squared. K to the all squared, not to this. I forgot. That's a mistake. Don't do it. I learned that this is here. So we have a common factor here and here, k plus 1. So we will take it out. K plus 1 is the common factor. Okay. All multiplied by k, 2k plus 1, and we will divide by 6 and multiply by 6. So we common denominator, so we can add plus 6 k plus 1 equal to divided by 6. So we will play with this term first. So it is 2k squared plus k plus 6k plus 6. So this will be 2k squared plus 7k plus 6. So we will do this. I do this thing. So a multiplied by c is 12 and b is 7. So we need two numbers that add to 7 and multiply to 12, which is, we clearly see it's 3 and 4. Okay, and we will write it as 2k squared plus 4k plus 3k plus 6, and we will group this term and this term. This is like factorization. Okay, and now we will take 2k here, and it will be with the rest will be here k plus 2, and from here we will take 2, and the rest will be 3. The rest will be k plus 2. So we have a common factor. So the factorization of that first term is 2k plus 3 and k plus 2. So yeah, well, let me insert a new page. So we will go back to this and we will write the factors. So it will be k plus 1 multiplied by k plus 2, or multiplied by 2k plus 3 all over the 6. And with this is actually our term. It is similar to this term that we wanted. We just need to write it differently, but it is equivalent. It's the same. So it's k plus 1, and this is what we want here. This is k plus 1 plus 1. This is right. And here we will take 2k plus 2 plus 1, and we will factor out here 2. So 2k plus 1 plus 1 plus 1 over 6. And that's our proof. We are done. Tomorrow I hope I will continue with linear algebra. So I will do a day calculus. The next day is number theory. Then the other day is next day will be linear algebra. And yeah, probably either Strang or because it has MIT lectures, open course, or because it will help me, or I will study Anton, which I heard is easier. And that's what I took in college before I dropped out. Okay, so see you guys tomorrow. Bye.